Hi there. In this lesson, you are going to learn binomial theorems and its different properties and applications. In this section, you are going to learn how to define a binomial theorem. So let's begin. Defining binomial theorem. For any positive integer n, x plus y to the power n is equal to nc naught x to the power n plus nc1 x to the power n minus 1 y plus nc2 x to the power n minus 2 y square, and then it keeps going, and the last term is plus ncn y to the power n. So basically this expression is known as binomial theorem. So technically what we are doing, we are adding two terms x and y, and we are trying to expand that two terms with an integer n, and if we do that we will get this expression. Now let's see how we can use this theorem to solve a math problem. So let's consider an example. So the example is expand the expression x plus 3 to the power 4. So as you can see, it is given that the expression is x plus 3 to the power 4. What I'm going to do, I'm going to use the binomial theorem, which is this theorem, to expand this expression. And if we do that, we will write x plus 3 to the power 4 is equal to 4c0 x to the power 4 plus 4c1 x to the power 4 minus 1, 3 to the power 1, plus 4c2 x to the power 4 minus 2, 3 square, plus 4c3 x to the power 4 minus 3, 3 to the power 3, plus our last term is 4c4 x to the power 4 minus 4 times 3 to the power 4. So if you look closely, you can see the power of x is decreasing, or I should say the power of first term is decreasing, which is x, and the power of second term is increasing with the expression. Now let's simplify this expression. So what we need to do, we need to simplify these combinations, and if we do that, we will get x to the power 4 plus 4 times 3 times x cubed plus 6 times 9 times x squared plus 4 times 27 times x plus x to the power 0, 81. So basically what we are doing, we are simplifying these combinations and writing their values, and that's how we get this expression. If we further simplify, we will get x to the power 4 plus 4 times 3 is 12, so I will write 12x cubed, 6 times 9 is 54x squared, which is over here, 4 times 27x is 108x, and then x to the power 0 is 1, so 1 times 81 is 81. And this is the expression x plus 3 to the power 4 after we expand using the binomial theorem. Now let's talk about some cases of the binomial theorem. So the first case is for x equals to x and y equals to negative y. So basically what we are doing, we are substituting the value of x for x and the value of y for negative y, and if we do that, our expression, this expression will convert into this expression. So basically I'm replacing y with negative y, and if we do that, our expression will become nc0 x to the power n plus nc1 x to the power n minus 1 times negative y to the power 1, which is basically negative y, plus nc2 x to the power n minus 2 negative y square. It keeps going, and the last term is ncn negative y to the power n. And if we further simplify, we will get this expression. So basically what we're doing, we are substituting the value of y as negative y in the binomial theorem, which is this theorem, and simplifying the expression. Now let's consider the case 2. So the case 2 is for x equals to 1 and y equals to x. What we are going to do now, we will substitute the value of x as 1 and y as x. And if we do that, we will substitute the value in the actual binomial expression, which is this expression, and we will get 1 plus x to the power n is equal to nc0 1 to the power n plus nc1 1 to the power n minus 1 times x plus nc2 1 to the power n minus 2 x squared, keeps going, plus our last term is ncn x to the power n. And if we further simplify, we will get this expression, which is basically nc0 plus nc1x plus nc2x squared plus nc3x cubed plus dash 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 plus ncn x to the power n. Let's consider a case 3. So case 3 is for x equals to 1 and y is equal to negative x. So if you see, I'm writing y equals to x, but apology for that typo, but consider that as y equals to negative x. So when we do that, we will substitute the value in the actual binomial theorem, which is this theorem. So we will write 1 minus x to the power n is equal to nc0 1 to the power n plus nc1 1 to the power n minus 1 times negative x plus keep going, and the last term is ncn negative x to the power n. And if we further simplify, we will get this expression, which is basically nc0 minus nc1x plus nc2x squared minus nc3x cubed plus dash 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 plus our last term is negative 1 to the power n ncn x to the power n. And again, this is negative x, not x.